Right, question 2 of the 2017 A-Level Maths C4 paper. Number 2, it's the implicit differentiation, finding the gradient of a curve question. Not generally too difficult, so let's have a look. We're going to do dy by dx of the equation, and of course, if it's in terms of y, make sure you write dy by dx after it. So let's differentiate that. That comes down to 6y5, but it's in terms of y, so write dy by dx after it. This is a straightforward minus 12x cubed. Here, differentiate with respect to x first, gives minus 18xy. Then differentiate with respect to y, we'll just leave the minus 9x squared. Don't forget to write dy by dx after it. 48 disappears and 0 stays as 0. The idea is then to get the two dy by dx terms together. So we can see we can factorize those two. Put 6y5 minus 9x squared together. Chuck it in a bracket with dy by dx outside. And let's take these two non-dy by dx terms over the equal sign. They're both minuses here. They'll turn into pluses over here. Then we can divide through by this to give an explicit expression for dy by dx, and there it is. It does say on the question to show it's this, however. So if we look, each of these has a numerical factor of 3. Divide all through by 3, and I get what they was asking in the question. No major problems there. Right, part B. Find the gradient of the tangent to C. Now, usually it gives us the coordinates. It doesn't on this one, but no biggie smalls because it's worth 3 marks, so we'll take that. Each of the points where C crosses the x-axis. Well, of course, when it crosses the x-axis, y is 0, so I'm going to substitute that in and find out my x-coordinates at the same point. So, going back to that original equation there, that's going to be 0, that's going to be 0, which just leaves me with 3x to the 4 equals 48. I divide through by 3, x to the 4 equals 16, and then your nerd skills got to come through here, although you could do the fourth root on your calculator, so x equals positive or negative 2. So the two coordinates are positive 2 and 0, and negative 2 and 0. Then you substitute both of these into the gradient of the tangent equation to get your two values of the gradient of the tangent at that point. And be careful pressing the buttons on your calculator. I would prefer it for you to do it in your head personally. Double check it at least twice. And the values were minus 8/3. And no surprise, it's symmetrical. Positive 8/3. No major problems there.